Hello all. In today's video, we are going to learn about the medium access sublayer protocols. We are learning about the data link layer, where the data link layer we have learnt about the flow control protocols in the previous video. Now we will move on to the sublayer of data link layer called as a medium access sublayer. As you can see that the data link layer functionality is divided into two sublayers. One is the data link control, which does the flow control, which we have learnt. We have learnt the data link layer protocols, flow control protocols. Then we have another sublayer called as multiple access resolution or medium access sublayer. What is the purpose of this layer? The multiple access resolution layer, it is responsible for resolving access to shared media. What do you mean by access to shared media? See, if we have multiple stations accessing the shared medium, single shared medium at the same time, which device has to be given permission to access or transmit is called as multiple access resolution. I have to resolve which among these three devices will transmit the data first. This is about multiple access resolution. For this we have many protocols like random access protocols, controlled access protocols and channelization protocols. In this video we are going to learn about the random access protocols. Why are the protocols named as random access protocols or the method called as random access methods? Because the station, when it is transmitting on a shared medium, will not have any scheduled time to transmit. It can transmit randomly anytime whenever it has data to send. That is why we call it as random access method. Now, if all the stations on a shared media will transmit randomly at any time, there is a possibility that the frame coming from this machine and the frame coming from this machine can cause contention. That will lead to access conflict. Who is going to use the shared medium? And that may lead to an access conflict called as collision. Now, why are these random access protocols required? These random access protocols are required to avoid collision. To avoid collision, we have four protocols. One is Aloha, CSMA collision detection, CSMA-CD, CSMA collision avoidance, CSMA-CA. We are going to learn each one of them. Let us start with Aloha. In Aloha, it's a random access protocol where it has two types. It has pure Aloha and slotted Aloha. Pure Aloha is a basic one, whereas slotted Aloha is an improvement over the pure Aloha. Let us understand what is pure Aloha. What is the idea is that whenever a station has frames to send, it will send the frame randomly. So there is a possibility that the frame coming from another station may collide with the frame sent by this station. And whenever a frame is being sent, the sender will start a timer, and as soon as the timer expires, the sender will go for a retransmission. There is a possibility that the other station also does the same. If it also does the same, again the second attempt may also lead into collision. So the idea of pure Aloha is to avoid this. Have a look here. Now you see station 1 has sent us its first frame. Now you can see no other station has sent its frame during this particular time. So no collision takes place. But if you can see, the second frame of the station 1 is being sent almost during the same time of the station 2. Likewise, the station 3 sends a frame during the same time, and station 4 also sends the frame during the same time. This leads to collision of frames, and due to collision all these frames have been lost or corrupted. So this is called as your collision duration, or it is also called as a vulnerable time. It is also called as the vulnerable time. Vulnerable means easily attackable. It is a time where the frames are being colliding, easily being attacked. So this is called as the vulnerable time, where more number of collisions are taking place. Likewise, here you can see at this particular time, the frame, the second frame from station and the station 2 and the second frame from station 4 are colliding, and both the frames get corrupted or lost. So what we have to do, whenever a station is sending frame and it is not getting acknowledged, it means there might be a collision and it will go for a retransmission, automatic repeat request, what we have learned. But if all the station try to do automatic repeat request as soon as the timer times out, then again the frames may get collided. So to avoid this, what we do is we go for a back off procedure. Pure Aloha will go for a back off procedure, and this back off procedure is whenever the timer times out, the sender will stop itself from doing a ARQ, automatic repeat request. Rather, it will wait for a random amount of time and then later it will transmit. While it was waiting during that random amount of time, the other station can send the data and the frame may avoid collision. So this amount of time, the random amount of time where the station is able to wait, that time is called as the back off time. And the other approach is, if the station has sent a frame 1, 2, 3, 4, 5, 6, 7, it has sent for some 15 times, still the station is experiencing collision, then what is being done is we will stop, the station will give up and will try after a later time. This is the other strategy. Now these two strategies we will understand using a diagram. You can see that the sender will start sending the frames. The number of attempts that a station has to take, we will set a maximum number of attempts as K max. Here you can see we have set the K max value as 15, and initially, because K is 0, the station will send a frame. After sending the frame, as you all know, as the station sends a frame, it will start a timer, and the timer is set as 2 times of propagation time. As you all know, propagation time is a time taken for the bits of a frame to receive the destination. 2 times of transmission time. Why we are taking 2 times? Going from the sender to the receiver, and for the acknowledgement to come back from the receiver to the sender. So I will take it as 2 times of the transmission time. Whenever this period is being elapsed, when the timer times out and the acknowledgement has not been received, if it has been received, then it is success. But if the acknowledgement hasn't been received, then what will I do? I will not go for an automatic repeat request. I will not go for a retransmission. I will go for incrementing the K value by 1. My second attempt, it becomes K equals to 0 plus 1, that is K now becomes 1. I will check the value, the number of attempt. Is it less than 15? If it is greater than 15, I have to abort my transmission. If it is less than 15, what I will do is I will choose a random number. And how is that random number being chosen? The random number is being chosen from 2 power k minus 1. The random number is chosen from the range 0 to 2 power k minus 1, where k is your number of attempts. Now because it is 2 power 1 minus 1, I will get 0 to 1. So I will choose a random number between 0 and 1 and substitute and calculate the back off time, the amount of time where the station should not send. R is the back off time that I have calculated, the random number that I have calculated, into the propagation time. For example, the time taken for a frame to be transmitted, average time taken is 10 milliseconds. So I will multiply what is my random number generated, for example 1 into 10 milliseconds. So what the station does, it will back off itself for 10 milliseconds and then it will transmit. While it is transmitting again here, again it will wait for a time period, and if the acknowledgement is not received, it will increment the value of k as 2. Now k becomes 2. When k is becoming 2, again we will check for the number of maximum attempts, and again we will take out a random number. This time the random number will be between 0 to 2 power 2 minus 1. So I will get 0 to 3. That means I can take a random number between 0, 1, 2 and 3, and I will get a for example, I'll take 3. So my back of time will be 3 into 10, for example. So I will wait for 30 milliseconds and send. So there is a possibility that the other stations were sending the frames can send during the time where I was waiting. So this way what will happen? This way it happens that the station will avoid collision with the other frames. If at all I go for the maximum 15 attempts and still I am not able to successfully transmit the frame, then I will abort the transmission. This is about your strategy of pure aloha. Now coming on to, just to explain you what is the vulnerable time. See, the vulnerable time is the time where the frames are colliding. You can see that if I said you that if it is taking for me for station A to go to get transmitted 10 milliseconds. So it should be in such a way that during this 10 millisecond no other station should transmit. What will happen? There will be a collision. And also no other station should transmit before this 10 milliseconds also. Because see, if you see before this 10 milliseconds here, for example, I have to transmit from 12 to 12:10. Okay, nobody should transmit during this time, as well as no station should transmit between 11:50 to 12 also. If there is any frame going through this time, there is a possibility that the end of this frame may collide with the beginning of this frame. Likewise, the end of this frame may collide with the end of this frame. Likewise, all the frames will be lost or corrupted. So how much is a vulnerable time? Vulnerable time of a pure aloha is 2 times the frame time. It is 2 times the frame time, which means that no frame should be transmitted during this 10 milliseconds and a 10 milliseconds before this. After 10 milliseconds, anybody can transmit. During this period, anybody can transmit. But if you transmit before this 10 milliseconds, then there will be a collision. Before this 10 milliseconds, if anybody transmits, then there will be a collision. Okay, so that means what we have understood, that the vulnerable time period of an aloha, pure aloha, is 2 times of the frame transmission time. Now, how do I calculate the throughput of pure aloha? Meaning, what is the efficiency of pure aloha? Why are we using pure aloha? We are doing pure aloha for avoiding collisions. So how many out of 100, how many number of frames will successfully be transmitted? So to calculate that, we have a formula called as S is equal to G into e power minus 2G. How are we getting this 2? We are getting this 2 using the vulnerable time period, which is 2 times. So if I do differentiation of this equation, I will get the value of G as 1 by 2. I'll get the value of G as 1 by 2, and when I substitute this 1 by 2 in this formula, I will get the value of S as 0.184, which means that 18.40% of frames will be successfully transmitted without collision in pure aloha. Okay, so this is your efficiency of pure aloha. What is the second improvement over pure aloha? It is slotted aloha. The principle of slotted aloha is very simple. As the name specifies, the available time of transmissions are divided into slots. We have to see to it that the station will transmit only at the beginning of its synchronized time slot. If your time is being given as 12 o'clock, you have to transmit sharp at 12 o'clock. After 1 millisecond also, if you transmit, you are not allowed to do so. Okay, this is how we will try to avoid the collisions. So like this, what we are doing is giving slots. We are making the vulnerable time period. We are making the vulnerable time period compared to pure aloha. We are reducing the vulnerable time by 1/2 of pure aloha. Let us understand by this example. See, the available time is being divided into slots. The stations have to transmit their data, their frames, only during this slot. See, frame 1.1 has been transmitted during its slot properly. So what has happened? There is no collision. But there is a possibility that the same slot might have been reserved or being taken, because these are random access. Though it is slotted aloha, it is random access. It's a possibility that both of us may start transmitting at 12:10. station 2 and station 3. So there's a possibility there will be a collision. Likewise, the station 1 and station 4 are transmitting at the same time. So it leads to collision. But you can see here no other station was transmitting during this time slot. So the collision is reduced. Here also there is no collision. Here also there is no collision. Here we only need to worry about this period, this frame transmission time, 1 frame transmission time. I am not worried about 2 frame transmission time as I was worrying in pure Aloha. So the efficiency of slotted Aloha compared to pure Aloha is more. It's almost double. See, the formula for efficiency of pure Aloha of slotted Aloha will be S is equal to G into e power minus G, where here I have only 1 G because the vulnerable time is 1 frame time only. So if I will differentiate this equation, what I will do is, if I go for a differentiation of this equation, I will get the value of G as 1. When I substitute the value of G as 1, I will get the value of S as 0.368, which means that 36.80% of frames are successfully transmitted out of 100 without collision. That means you can see it was 18%, 18.40%, which is in pure Aloha, and slotted Aloha it is 36.80%, which is exactly double than the pure Aloha. So these are the two protocols, pure Aloha and slotted Aloha, for random access control. Thank you.